Hello everyone. Now we have to discuss the parameter representation of two-port network analysis. So in that we have to discuss impedance parameters, admittance parameters, transmission parameters and hybrid parameters. Now we have to discuss the first type of parameters, that is impedance parameters, that is ZParameters. We can call it as open circuit parameters. Okay. Can start the discussion now. We know that for any two-port network, first we have to draw that circuit model. Let us say this is the rectangular box. In that we have a network, right? Okay. This is one port. This is another port, right? So this is the current through port 1 entering and leaving, like that. This is the current through this port 2. And what about the voltage? This is V1, this is V2, right? Plus minus, right? So V1 is the input voltage, I1 is input current, V2 is output voltage, I2 is nothing but output current. We can write in, out. This is two-port network. That's it, right? So to represent impedance parameter, now we can draw how we can represent the Z parameters in two-port network is, now we have to discuss, right? The current through this is I1 across we have V1, across we have V2, entering current is I2, leaving current is I2. Okay, plus minus. Now we have to write the impedance as Z11, Z12, Z21, Z22. Now we have to discuss what is this Z11, Z12, Z21, Z22. So in case of impedance parameter, we are going to represent the two-port network model like this. This is the two-port network model for impedance parameters. Okay. We all know that V, which is equals to what? I into Z, right? Now we have to represent this model in matrix form. This is V, right? This is Z, this is current, right? So from this, V1 is the input supply voltage, V2 is the output supply voltage. Therefore we can write V1 V2, which is equals to Z11 Z12, Z21 Z22, like that, which is multiplied by I1 I2, right? So this input and output voltages are nothing but what? Dependent variables, right? These are what? Independent variables. So we can represent the two-port network model in Z parameters like this. So from this we can get the matrix notation of Z parameters like this. So we all know that V is equals to I into Z. From this, V1, V2 are nothing but input voltage, output voltage. Like that, I1 is input current, I2 is output current. So with that, we have represented the Z parameters, Z11, Z12, Z21, Z22. Now from this, we can write V1, which is equals to what? Z11 I1 plus Z12 I2. Like that, V2, which is equals to what? Z21 I1 plus Z22 I2. That's it. This is the representation of two-port network. These are the equations in Z parameter representation based upon that matrix notation, right? So from this, I1 is input current, I2 is output current, V1 input supply voltage, V2 output voltage. Now we can start the discussion with respect to the name itself. Open circuited parameters means what? When it is open circuited, obviously what will happen? There is no current, right? So first we have to assume output port is open circuited, right? That is, what is that meaning? Output port is open circuited means what? That is I2, which is equals to 0, right? From this, when I2 is equals to 0, what we are going to get? We are having V1, which is equals to Z11 I1, right? From this, Z11, which is equals to what? V1 by I1, right? When I2 is equals to 0, this is the value of impedance Z11. This is Z11. Clear? Like that, when I2 is equals to 0, from this second equation, V2, which is equals to what? Z21 I1. From this, Z21, which is equals to what? V2 by I1, right? Simple. Notation is what? Z21. This 2 represents what? Voltage. This 1 represents what? Current. That is output voltage by input current. Like that, Z11 means what? Obviously impedance is what? V by I. That is input voltage by input current. Right? When I2 is equals to 0, I2 is equals to 0, that is open circuited output, that's it. Okay, now output side is completed. Now let us assume input port is open circuited. Assume that is I1, which is equals to 0, right? When I1 is equals to 0, what is the equation? V1, which is equals to Z12 I2, right? From this, Z12, which is equals to what? V1 by I2. Like that, V2, which is equals to what? Z21, I1 is 0, right? Sorry, Z22. Z22 I2. From this, Z22 is what? V2 by I2. That is, from this, V1 by I2, input voltage by output current. Z22 means what? Output voltage by output current. when what, when I1 is equals to 0, that is open circuited input, right? Open circuited input. So finally what we have Z11, Z21, Z12, Z22. Now we have to write the names of that individual impedances, right? We are having what, Z11, which is equals to what, see, the first notation is what, V1, that is V1 by I1, right? Like that, Z12, that is V1 by I2, like that Z21, which is equals to what, V2 by I1, Z22, that is what, V2 by I2, completed. Then the names of this, which is equals to Z11, V1 by I1, this is nothing but what, input driving impedance. Like that, this is what, Z12, that is input voltage output current, right? That is reverse transfer impedance. Why it is reverse transfer? Because the current is what, output current, that's why it should be named as reverse transfer impedance. From this, Z21 is what, V2 by I1, this is also transfer impedance, but the current is what, input current, that is forward transfer impedance. Coming to this, Z22, this is what, output driving. Why it is output only? Because output voltage by output current. Like that, Z11 is what, input voltage by input current, that's why output driving impedance. What are the units? Ohms only, right? Ohms, ohms, that's it. Z11, Z12, Z21, Z22. So in case of Z parameters, these are the values of individual impedances. Now we have to get the equivalent circuit of this Z parameter representation. Equivalent circuit. This is very, very important. We know that V is what, dependent variable, current is what, independent variable. So in case of Z parameter representation, voltage is dependent variable, current is independent variable. That is, what is that meaning? That is, the value of voltage is controlled by current in the circuit. So the value of voltage is controlled by current in the circuit. So for that, here I am considering this equation. Consider first voltage equation is what, V1 is equals to Z11 I1 plus Z12 I2, right? In this, first V1 is equals to Z11 I1, right? When it is V1 equals to Z11 I1, when I2 is equals to 0. From this, Z, or you can write C. From this, input voltage is depends on what? Input current. Input voltage is depends on input current. Depends on input current, right? All of you listen carefully, this is very important. How we can get the equivalent circuit? This is the perfect explanation for that. Okay, here from this first equation, when open circuited secondary, sorry, not secondary, output terminal, input voltage depends on input current only, right? Now we have to consider second, when I2 is equal to 0, what is the other equation? Or by considering this first equation, when I1 is equal to 0, V1 is what? Z1 to I2, right? When I1 is equal to 0, V1 equals to Z1 to I2. That is second. V1 is equals to Z1 to I2. This is what when I1 is equals to 0. In this case, what is the observation? See, input voltage, output current. The input voltage is controlled by output current. Means what? Controlling quantity is current only. This input voltage is controlled by output current. That is, controlling quantity is output current. In this case, that is, we can represent with current control voltage source, right? We can say that current control voltage source. Okay, so we can represent Z1 to I2 as current control voltage source. That is, V1 is equals to Z1 to I2, right? This is the value of voltage. So in order to represent that voltage, this Z1 to I2 can be treated as what? Current control voltage source. That is like this. Plus minus means what? Voltage, right? This is Z1 to I2. So like this we have to represent. Okay. What about first case? Here input voltage depends on input current. So Z11 is connected in series with the supply voltage. That's it. Because the connected in series means what? The current through the branch is nothing but because of the input supply voltage only we are having input current. So we are connecting Z11 in series with what? This current control voltage source. Current control voltage source, CCVS. Okay. Now considering second equation. Now second equation is what? V2 which is equals to Z21 I1 plus Z22 I2. First we have to consider, let us see, this is third case, right? V2 is equals to Z21 I1 when what? When I2 is equals to 0. In this case, see, in this case is what? Output voltage is controlled by input current. Output voltage is controlled by input current. Therefore, we can represent it with what? V2 which is equals to Z21 I1. We can represent it like this, right? Plus minus like this. Okay. This is also current controlled voltage source, CCVS. Fourth one, V2 is equals to Z22 I2 when what? When I1 is equals to 0. See, output current is controlled by output voltage is controlled by output current only. No problem at all. Right? Output voltage is controlled by output current. Therefore, Z22 is connected in series with this current control voltage source. That's it. Finally, therefore, the equivalent circuit for representing ZParameters is this is the input supply voltage V1. Clear? Input supply voltage V1. Then Z11. This is Z11. Clear? This is what? Like this. Like that. That's it. Now we can, this is what? V2. Okay, this is V2. Then due to this we have current I1, this is I2. Now we can write this is what? Z11. This is plus minus. What is the equation? V1 is equals to Z11 I1 plus Z12 I2. This Z12 I2 is nothing but what? Current control voltage source. Z21 I1 plus Z22 I2. Listen carefully. This is what? Current control voltage source, represented as CCVS. So this is what? Z12 I2. This is what? Z21 I1. That's it. See, from this V2 is equals to, you can write plus minus plus, apply KVL. That's it. Okay. This is I1. From this current direction, this is I2. Apply KVL. That's it. V1 is what? Z11 I1. Z11 I1 plus Z12 I2. Satisfied? Like that, V2 is what? Z22 I2 plus Z21 I1. This is Z22. That's it. This is the equivalent circuit of ZParameters. Means this is the application of KVL, right? See, voltage balance equation, V1 is IZ plus IZ, voltage balance equation, right? From 1 and 2, V1 and V2. That's it. Now I will take one example to clear the concept. So why we need this Z parameters? So for that, here I am considering a circuit. simple circuit T network. Okay, right? The impedance for this is nothing but, for example, 3 kilo ohm. This is what, 5 kilo ohm. This is what, let us say 12 kilo ohm. We all know that the current through this branch is nothing but I1. This is what, I2. The input supply voltage is what, V1 plus minus, like that. This is V2 plus minus. Then we can calculate. See, this is I1, this is what, I2. Now we can calculate Z11 and Z22. What I said, this is the application of KVL. Therefore, from loop 1, what is that? V1, which is equals to 5 into I1 plus 12 into I1 plus I2, right? Simple mesh equation, I1 plus I2, like that, completed. From loop 2, what is the equation? I2 plus 12 into, that's it. So 5 I1 plus, this is the mutual resistance between 1 and 2, therefore 12 into, based on the current direction, I1 plus I2, like that. In loop 2, V2 is equals to 3 I2 plus 12 into I1 plus I2, that's it. So from this, V1, which is equals to 5 I1 plus 12 I1 plus 12 I2, which is equals to V1 is equals to 17 I1 plus 12 I2, like that. V2, which is equals to what, 3 I2 plus 12 I1 plus 12 I2, which is equals to what, sorry, which is equals to 12 I1, right? What is the answer? 12 I1 plus 15 I2. 12 I1 plus 15 I2. This is V2. So this is 1. V1 equals to what? Z11 I1 plus Z12 I2, like that. V2 is equals to what? Z21 I1 plus Z22 I2. By inspection, you can say that Z11 is nothing but 17 kilo ohms. Z12 is nothing but what? 12 kilo ohms. Z21 is nothing but what? 12 kilo ohms. Z22 is nothing but 12 kilo ohms, right? This is the data we got. So by inspection, this is what? V1 equals Z11 I1, Z12 I2, like that. V2 is equals to what? Z21 I1 plus Z22 I2. So by inspection, Z11 is what? 17 kilo ohms. This is what? Z12 12 kilo ohms. This Z21 12 kilo ohms and Z22 15 kilo ohms.